Greetings everyone. Today we're going to discuss the third question which was asked by the Codeforces in its latest round. So name of the question is make the permutation. So what just the question state? We just took that. It's given that we have integer array A having a length n, and there are two kinds of operation which we can perform. Remove an integer from the A, and this operation will cost us C. Insert an arbitrary positive integer x at any position A, okay, and this operation will cost D, and we make the final array to be a permutation of any positive length, right? And it's also given that the final array must contain at least one integer, it should not be empty. So let's just see the input format. The input format is what? The T, and then it's given the NC and D, which is total length, cost of removal, and cost of adding a number, and then it will contain the elements, and the total it's given, it will not exceed the 2 into 20 per 5. So let's just before solving this question, let's see the what are the key observation which we can see here. Okay. I'm recording this video second time because in first time there was some sort of error. So what are the key observation which we can look before starting this question? The first observation was that we should sort the first observation was that we should sort this vector, or whatever they say, array. And first observation that we should sort the array. And why we should sort the array? Because here what we have the concern of finding the the minimum cost of the permutation, minimum cost to make the permutation, right, after performing certain number of operations. Here the order is not important. And second, that if we sort the array, then it is quite easy for us to knowing the missing element between any two consecutive element. For example, if given it's like 4, 3, 1 and 5, and if we sort this, then it will become 1, 2, 4 and 5. So it will be quite easy for us to find the missing element between any two consecutive number. For example, missing element between these two is 0, missing element is 2 and 4 is 1, and between this is 0. It will be quite easy for us. Second observation is that if there is any repetition in the number, for example, if any number do not has the frequency as 1 or more than 1, then we have to remove all the repetition. If we have given 1, 1, 1, 2, 2, 5, 5, 4, then we should remove 1, 1, and we should remove 5 and 2 to make the frequency of everything as 1. And why we are doing that? Because to make the permutation of any positive number, the frequency of each number should be 1. So no matter what the given array is, my initial cost will be what? My primary cost will be always equal to, my primary cost will always be equal to the number of array which we have, number of elements which we have removed to make it array which is in which the frequency of each element is equal to 1. So here it will be what? It will be 4 into cost of removal, let's say that be R. So it is my primary cost. It was the second observation. And my third observation is that if I sorted the array, and my resultant array after sorting and removing the sorry, not like that. So after sorting and doing removal of the duplicate element, it will look like this. So I will move from the back to front, from here to here, and while I am moving at each index, what I will state that I want to make the array which is the permutation, which will be the permutation of 5, or which is the permutation of 5. So to make an array which is a permutation of 5, what we have to do? We have to remove all the elements. We have to remove all the elements which are greater than 5, right? And we have to add all the elements which were less than equal to 5 and missing in this array, right? For example, if I want to make the permutation of 5, then what are the minimum number of operations I have to perform? The minimum number of operations which I have to perform will be what? My answer will be somewhat a minimum of my all the previous states, right? And all the numbers which are at left. So number, if I am at ith indexing, so what is the number of elements which are at left? N minus I plus 1. right? These are all the numbers which are at my left, right? Into the cost of removal plus I have to add the add all those number which are smaller than this and which are missing. So we can store all the numbers, the number of total number of missing element till ith indexing in a variable, right? And let's say the name of the variable is total missing. As the name clearly state, the total missing will state the all the missing element till ith state, each ith state, right? Into the cost of appending that element, right? So at each step my answer will be this only, and among all the possible answers I will store the minima. For better understanding, I will state that I want to make the array which is the permutation of 5, right? Then I will move to 4, and then I will move state that what I want to make an array which is the permutation of 4. So I should remove 5, right? And I should add 3 because 3 is the only number which is less than this and missing. Then I will move at 2, right? Then I will tell what I want to make the array which is the permutation of 2. So what we have to do, we have to remove this part, right? 4 and 5, which will be managed here, right? And the cost of removing the element, and I have to add a total number which are less than equal to 2 and missing. So it's 0 here, so that part will be 0. So this was my entire approach. Let's just see a sample test case and try run on that. So the sample test case was given the question 151, if I am not wrong, and it was 1 2 3 5 or something was like. Let me see the sample test cases. So I'm taking this sample test to 1 2 3 5 and 6. 1 2 3 5 and 6. So I will follow those steps only. First I will sort the entire array. So it is only sorted order, so it will be what 5 and 6. And then I have to store what I have to, for second, then I have to remove all the repeating elements. So my primary cost will be what? My primary cost will be 0 here, as the no number is repeating here, right? So now what I will do, I will make a temporary variable, like it will store the total count, total missing element, right? Total count, or whatever its name. Let me see in the code what name I have used for consistency only. Total rank. Okay. I'm just taking a total count only. Okay, and I will initialize it will be 0. And what this will be stored? This will be stored the total number of missing elements, in this entire array, from I is equal to 0 to I is equal to n minus 1. And I will make a cost vector. And what this cost vector will store? The cost vector will store the number of missing element between the any two consecutive pairs. For example, the cost between the 1 and 2 is equal to 0, cost between 2 and 3 is equal to 0, cost between 3 and 5 is equal to 1, and cost between 5 and 6 will be 1 only. So okay, and I will approach this in this manner only. Let's just dry run only here, and then when we will move to code, then I will explain the rest of the things which I have used. So we will move here. Our answer will be what? Our answer will be equal to the min of answer comma n minus I plus 1, right? It will be n minus I it should be not n minus I plus 1, it should be n minus I minus 1. Okay, so because when we add I, it should give us 0, right? So in that sense it should be that only, because so fine, I guess n plus 1, and the cost of removal plus the number of missing element which you are storing in what? The total count into cost of appending, right? So let's just do a dry run on the sample test case which I have taken. It is 1 2 3 4 1 2 3 not 4 1 2 3 5 and 6 5 and 6 and it's an R A cost of removal. Here the R is given as 1 and A is given as 5. Okay, let's just so we will move from where? We will move from I is equal to, let me write the indexing, from 4. So what is the answer at 4? The answer at 4 is equal to, we will initialize the answer as int max. So it will be what? The min of answer, comma, the number of element at its left. So at its left is 0 into cost of removal plus number of elements in its right which are missing. So here only one number is missing. So 1 into 5. So cost is here is 5. Right, till I is equal to 4, the cost is equal to 5. When I will move at 3, so my answer will be what? The min of 5, comma, remove all the elements which are at the left. So it will be 1 into cost of removal is what? 1 plus add all the elements which are 5 and missing. So it is the 5 only. So this will generate 6 and minimum of 6 and 5 is equal to 5. Then we will move at I is equal to 2. And what will happen at I is equal to? The answer is equal to what? The min of answer, comma, at 3 the number of elements which you have to remove is equal to 2, right? Because two numbers are at its left and the cost of removal is 1 plus we have to append all the elements which are less than 3 and missing. So the no numbers which are less than 3 are missing. So it will be 0 into whatever the 5 it is. So cost will be 2. And in similar manner, if we move from the 1 and 0, we will get the same thing. One thing is to note here is that there will be a case, okay, there will be case when we will remove all these elements, that we will remove 1 2 3 and 3 5 and 6. We will remove all this element and we will add that element. So when we will exit from the loop, we must check this edge case, right, which is what? The min of answer, comma, we will remove all the elements plus we will add the element where the n is what? The n is what? The original size. To keep in mind, the original size of given by in the question, the original size which was given in the question. So this was the whole approach here, right? That first of all we will sort the array, we will take the primary cost to make the frequency of each the element is equal to 1, and then primary cost, and then we will move from the back towards the front, and at each indexing we will try to calculate what will be my total cost if I want to make the permutation equal to ARR of I. Basically, if I want to make the permutation which ends at I, and we will calculate the value, and we will finally report the minimum answer across all the answers, right? So let's just see the code for the better understanding, and the things which I have used extra in the code I will mention here. Just in question, like in explain that I have used the n, r and a, and I have declared a vector. I have stored the primary cost, which will store the cost to make the array where each element having the frequency as 1. So I have used an unordered map to track the frequency of each element. Whenever I take the input, I will check if the frequency is not equal to 0. If it is not equal to 0, then I have to remove that element, and cost to remove that element is equal to r, and else I will push that element into my vector and then increase the frequency of them. I have reinitialized the value of n as v.size. And why have that done here? Let's just see that. I think it's quite obvious, but for sake of mentioning, I am mentioning this. Suppose I have 1 1 1 2 2 3 5 5, right? So when I was taking element, I was making sure what my after taking the input, my array should not contain the any number which are having the frequency more than 1. Basically, I want to make the frequency of each element as 1. So I will remove these two elements. I will remove this element, and suppose there is also okay. So I will remove this element. So after removing, my element will be what? 1 2 3 and 5. And all the approach which we have discussed here, we have discussed in this is this vector, this types of vector only, right? Where the frequency of each element as 1. So that's why my cost of effective array will be the length of my effective array is equal to what? The 4, right? And by taking that only, we will store the further thing and calculate in further manner. That's why I have reinitialized the size as v dot size. So we will sort that array. We will I have make a variable as check is equal to 1, which will act as basically a counter. I will explain this part. Okay. What I have done in this part only, let's just see. What I have done here is that I have declared a variable dot check, which is initialized at 1, and I have make the vector cost, right, which is equal to size of n, the size of effective array, and I have initialized each value as initially as 0, right. And let's say I have the array as 1, 2, 4 and 6, right. It is my array. So what we will do, I will move in this array and at each index I will check what, whether my check is equal to I. If my check is equal to I, then I will what, I will just move to check to the next value, and if it is not equal to I, it means what, the numbers are missing. So what I have done here is basically what, that if check is equal error of I, basically the elements are equal, then I have just increase the value of check. What will the value of check will be? The value of check will be error of the next value after error of I, right. And if it is not equal, it means what, the number of some number is missing. For example, here the value of check will be 2. Now the no number is missing here, so it will move here. The value of check will be 3, but here the element is 4. It means what, the one number is missing. So we will store that in cost array. So else cost of I is equal to absolute difference between the check and error of I, right. It's the absolute difference, and we will move to check to what, now my updated value of check will be error of I plus 1 only. And in total cost, I will simultaneously calculate the total missing elements, basically the cumulative sum of cost. So it will be plus equal to cost of I. So basically the check will tell us whether the element is missing or not, right. And the cost of n will store the total number of missing element, basically it will store the missing element between any two consecutive pair. For example, the between 1 and 2, the no number is missing, so here it is 0. Between 2 and 4, the one number is missing. I have done something wrong here. This should be this number should be here. So between 2 and 4, the one number is missing, right. Between 4 and 6, one number is missing, so it will be 1 here. Between 6, there is nothing like that. So yeah, so this is the configuration. So between 1 and 2, the no number is missing. Between 2 and 3, no number is missing. Between 3 and 5, between the 1 is missing, right. So that thing I have just done it only and stored that thing in my cost array, and I have just calculated the cumulative of all these things into a total cost. So I have declared a cost vector here, right, and a total cost. I'm moving from I is equal to 0 to I is equal to n, and I am checking whether my v of I is equal to check. If it is equal to check, means what, the no number is missing here, right. So just I have to move to next number, and if it is not equal to check, it means what, the some number is missing, just as we have discussed. So we will move to check to where v plus I, and total cost is equal to what, the total cost is the cumulated cost, which is cumulated of all the missing numbers, the total number of missing numbers I have stored in the total rack. Now what I have done here, that I have initialized my answer as equal to int max, and at each indexing, what I am telling is that I am telling it that my answer will be the minimum of my previous answer, or the total element, the total number of missing element till the ith indexing. What do I mean by this? Suppose we are at 1, 2, 4 and 5, and I will move from here. So what is the total number of missing element here? Total number of missing element till ith is let's consider this as 6. So total number of missing element is what? The one here and one here. So total number of missing element is what? 2, right? So the 2 into cost of adding plus cost of removing the element which are smaller than 6, right? And we will store the minimum. So that thing was only done here. The total rank will store the total number of missing element till the ith indexing, right? And at each iteration I have reduced the cost of total rank. Why I have reduced? Because when I will move from 6 to 4, the total cost will store what? The total number of missing element before 4. So I should remove the total cost missing between the 4 and 6, right? So I have to remove that value. That's why I have just removing that value from the total rank. And after calculating everything, my answer should be what? My answer plus my primary cost, right? And the edge case just I have explained here. The similar edge case I have used here. It is n into r. Here the n is the updated r. Let me give you the example. Suppose my array was something like this. So I have just removed this, and this. So my updated array was will be like this. So that edge case will be what? My edge case will be the mean of answer, comma, I will remove all the elements. By removing all the elements with what? I have already edited the value of n. So it will be what? 4 into r plus cost which I have bear to remove these three numbers. So primary cost plus when I will remove all these elements, I have to add a new element, right? I have to add a new element because the array cannot be empty. So the cost of adding a new element, which is basically what? Which is basically the cost of adding a new element. So that thing was here, and I have just printed the C out or printed the answer. So this was my whole code and approach. The main takeaway, or main highlights of this question was that first we have to do the sorting. Why we have to do the sorting? So that we could easily calculate the number of missing elements between any two consecutive element pairs, right? Once we have done the sorting and calculated a minimum element missing between any two consecutive pair, then we have to move from the back. Why we have to move from the back? Because at each indexing, what we are stating that when we are moving from the back, at each indexing we are stating that I want to make the permutation of ARR of I, or the permutation that ends at I. So I will remove all the elements which are at my right, and I will add all the elements which are missing, or I will append all the elements which are at my right, basically the left and smaller and missing. All the elements which are at I will append all the elements which are at my left and missing. So I will attempt all those elements. When similarly when we are moved to any other, then we are doing same thing, that we will remove all the elements at our right and add all the elements from our left which are missing and which are less than C, to make the permutation of any number, let's say C. So that was the complete approach and highlights. If we talk about the time complexity of the code, we are performing a sorting here which will be equal to what? N log n and map will store the O of 1 only. So the complexity will be what? The complexity will be t into n into log n, and so this was the complexity. If I have to write here, so complexity of this code will be what? The complexity of this code will be the number of sample test cases plus n log n plus one for loop which we have run is n. So it will be something about the big of t into l log n. So yeah, and it is given that t into n is equal to 10 to the power 5, so it will comfortably run within 1 second, right? Because so it was the time complexity of this code. I hope you understand the entire code and the solution and my approach. If you have any doubt, then feel free to ask in the comment section. Thank you and have a